Hi guys, how's it going? In this tutorial, I will show you how to do this parametric fence. Let's have a look at the images first. Cool. And you can download all of the materials from our website. Let me show you the fence. In this tutorial, I'm going to do this fence in a simple way. And in the next tutorial, I'm going to show you a little bit more complex way to do this fence. Cool. First, let's have a look at the comments we will learn. The first comment is divide curve, the second one is linear array, and the next one is flip matrix. Before we use Grasshopper, we need to draw some lines in Rhino like this. Cite this curve into the curve comment, this one, right click and cite one curve. Then I'm going to use divide curve to show the control points. You can see there are some green control points here. And the count, I set 9, and you can change it. And then I use linear array. I want to array these points, not the line. So I connect the points to the geometry, and direction is X direction. And the gap between each point is 3. You can see the gap is 3, and the count is 34. You can change the number what you like. And in the next step, I move all of these points to another place. If I disconnect here, and you can see I move all of the points here, right? If I don't use reverse command, let's see what will happen. Connect the motion to the unit Y, and you can see all of the points move to this way, right? Because here is Y direction, and if I use reverse, it will move to negative Y direction. Okay, and then use pull point to do some interference. If you are not very good in interference, you can have a look at our previous interference cases studies, and we can connect all of the points to the point here. Geometry connect to the point, and this curve we use multiple curves, cite multiple curves, and cite these two curves. And here I'm going to change it from 5 to 11 because I want to move all of these points from 5 units to 11 units in this direction. Okay, and also because I cite these two curves, you will know the closest points here will move the shortest distance, and the furthest points, like here, will move the furthest distance from 5 to 11. And if we connect them together, you will see the result. And you can see these points are the closest part to the curve, and these points, you see, this distance is very far, right? They move the furthest distance. And if I exchange the connection between them, the closest points, like from here, you can see these points are closest to the curve. But after moving, you will see they move the furthest distance. And in the previous step, this part of the points, if I click it, are furthest to the curve, right? But after moving, they move the shortest distance, as you see. If you still don't understand these principles, you can have a look at our previous tutorials. It will help you a lot. And then in the next step, connect all of the points together. Use NURBS curve. If I connect them directly, you can see all the points connected horizontally. but I want to connect them vertically, so I can use flip matrix. It's under the size options. You can find it from here, under the size, and find flip matrix. Connect them together. Click here, you can see they are connected vertically. Cool. And also I need to connect all of the original points. Use this one, copy and paste the NURBS curve and flip matrix comment. Copy and paste them to here and connect to the geometry. This is all the points. Connect them together, get the result like this. And then I'm using the loft to create the surface. And in the final step, extrude them in the X direction, as you see. And also we can use multiplication. Not this one. We can use multiplication. This is the distance between the gap. Maybe we can times 0.3 and connect it to here. And you can see the pattern thickness is 0.3 of the gap. Cool. Let's have a rest, and then I will show you how to do this panel in a more complex way.